Hello dear students, hope all of you are doing well. Here is our another video lesson on chapter electricity. Last 2 years, CBSE question paper we are going to analyze from this chapter of different regions. We collected these questions. So please follow it thoroughly and prepare on it. You have to see the question and get your own answer. Then compare the answer with me. Let's go for the first question. The maximum resistance of a network of 5 identical resistors of 1.5 ohm each can be. So we have 5 resistors of 1.5 ohm. What will be the maximum resistance you can get it? We have studied in this chapter for resistors to get an effective value. Either we can connect them in series or they can be in parallel. In series combination, we know that the net resistance increases and we get the maximum value. In parallel combination, we know that the resistance get decreased and the least value of the resistance will be there. So to get maximum value, of course, it should be conducted in series combination. So maximum resistance we have to find out how many are there, 5 are there and each 1.5 ohm. So we have to get the maximum. All of them should be in series combination. As a first idea, so series combination. In series combination, we know resistance in series Rs is equal to R1 plus R2 plus R3 plus etc. You have to add all together. We have 1.5. How many are there? 5 are there. So you have to add all together. Now, one shortcut you might be gone through. Rs is equal to N into R. If R, all of them are identical values, then R is the value of one resistance, then N times. How many are there? That number of times. Each one will be the net resistance. So number of resistors times into the value of one resistance will be the total resistance of identical resistors in series combination. So here we can see Rs will be equal to how many we have? 5 we have into 1 by 5 you will get 1 ohm. So 1 by 5 ohms, how many? 5 are there? We count in series, so we get 1 ohm is the maximum. That is the answer. Have we got it? Now the same 1 by 5, if you connect in parallel, then the effective resistance we can write as 1 Rp is equal to R divided by N. Another one logic approach you can do it. Identical resistance value of R divided by number of resistors will give you the effective resistance in parallel combination, and that will be the least value you can get from these 5 of them. Hope I got it. Let's go for the next question. Study the IV graph. Here see IV graph is given for 3 resistors of resistances R1, R2 and R3, and select the correct statement from the following. So we have 3 resistors, is IV graph is given. The relation between current and voltage is given. So here I is taken on y-axis, voltage is taken along x-axis. You know Ohm's law, one of the best application is we can find the unknown resistance from the graph, relation between V and I. So if it is VI graph, voltage along y-axis and current along I-axis, then the slope or the gradient gives you resistance. If it is IV graph, I is there, V is there, and it is there, then slope will be equal to 1 by R. Reciprocal of resistance will be. Slope means the gradient. If angle is given, then theta you can find out, and tan theta will be the slope or the gradient. So y component divided by x component is the slope. So here y component is I, x component is V. So I by V will give you the reciprocal of the resistance 1 by R. So in this graph, the relation see R1 equal to R2 equal to R3, R1 greater than R2 greater than R3, R3 greater than R2 greater than R1, like that combination is given. So here, since it is IV graph, the reciprocal of resistance will be the slope. So reciprocal is greater means resistance will be smaller. So here R1 has the greater slope, R2 has the second, R3 has the least. So in IV graph, which conductor have least slope? least slope will have greater resistance. Because it is, slope gives you the inverse, the reciprocal value. So here R3 will have the greater resistance here. R3 is first, R2 is second, R1 is third. So R3 is greater than R2, greater than R1 is the value. So C is the correct answer here. Now one more logic you can see in the graph, either IV graph or VI graph. The line near to voltage axis, the line near to voltage axis will give you the maximum resistance. Please keep in mind, the line near to voltage axis will have greater resistance. Keep in mind. Let's go for the next question. SI unit of electrical resistivity is, one of the easy question. Electrical resistivity, we know we have rho is equal to R into A divided by L, where R is the resistance of the conductor, A is the area of cross section, L is the length of the conductor. So R into A divided by L is rho. If you substitute the values of the units of each one, R we have the unit ohm. Area of cross section we have the unit meter square. L length we have the unit meter. If you calculate it, we'll get ohm meter is the value. So final answer is ohm meter. C is the correct answer. Ohm into meter. So some students used to be by heart the concepts, so sometimes they write ohm per meter like that. So it is ohm into meter. So C is the correct answer. Resistivity, you should have the definition of resistivity also. Okay, it is the resistance offered by the material of a conductor of unit cross-sectional area per unit length. Let's see the next question. The minimum resistance which can be made using 5 resistance each of resistance 10 ohm is. Look like nearby question we done as first. I gave the idea there also. Minimum resistance to find out. That should be contained parallel. Yes, you got it. So maximum resistance you should contain series and minimum resistance you should contain parallel. So 10 resistance each one. We have RP, 1 by RP is equal to 1 by R1 by 1 by R2 plus 1 by R3 plus etc. So here in general we can write R by N. If all of them are identical resistors, same values, then parallel combination RP will be equal to value of the one divided by number of resistors. So here 10 and how many are there? Total we have 5. So that gives you 10 divided by 5 are there. So that will be 2 ohm is answer. So final answer here, it is 2 ohm. C is the correct answer. Series and parallel combination. Again another question in one region. Take care about this concept. Here is the next question. Study the following statements. A fuse in a circuit prevents damage to the circuit due to overloading. B. Total resistance in a circuit increases due to overloading. During short circuiting, the current in the circuit abruptly increases. In order that each appliance has same current, they are connected in parallel to each other. The correct statements are, so it's regarding parallel combination of devices. The same concept is applied in our daily life in domestic circuits. So this question you can consider as that of a magnetic effect chapter also. Here, the concept is, so which all statements are correct here? First one, a fuse in a circuit prevents damage to electric circuit due to overloading. Sure, of course. In overloading, current increases abruptly. So the devices may get damaged. At that time, electric fuse will melt and it will save the circuit. So that is correct statement only. A is correct. B. Total resistance in the circuit increases due to overloading. No, total resistance decreases only. So only current increases abruptly. So it is wrong. B is wrong. Now C. During short circuiting, the current in the circuit abruptly increases. Sure, that is correct. C is correct only. D. In order to that, each appliance has same current. They are connected in parallel to each other. No, in parallel combination, it have different current. Is it? Same voltage will be there. If they have same current they need, then better to contain series combination actually. But in domestic circuit, the devices which has 5 ampere range or 10 ampere ratings, they are all connected in parallel, because if one device stop working or damaged, the others can still work. In that aspect, we connect them in parallel. So here, A is correct and C is correct. So here given A, C is correct. And here, in order that each appliance has same current, so each appliance in our, suppose domestic circuit need different appliances, like some are there need 5 ampere, some are there need 10 ampere, some are there need 15 ampere. Then they cannot be connected in series, they all connect in parallel. Okay, so the best answer is here C. A and C is perfect answers. D, it can be, so but here is given same current, then in parallel. If all of them have same ratings, then only same current can be connected in parallel, otherwise you cannot. Next question we can see. In case of 4 wires of same material, so same material is there, the resistance will be minimum if the diameter and length of the wire respectively are. So it's a logic question. Resistance depends upon the nature of the material, length of the wire, and area of cross section, and temperature also. 4 factors the resistance depends. So in resistance, nature of material is same here, 4 wires, so all of them have same resistivity. Then we studied the resistance R is equal to rho into L by A. Resistance is directly proportional to length and inversely proportional to area of cross section. So as the length increases, resistance increases. And as the area of cross section increases, resistance decreases. Okay, here material is same, hence resistivity will be same for all the 4. Then L and A, L by A ratio you have to check. If it is minimum, then resistance is minimum. So which of them have minimum resistance is there? Which option we can say? A, D by 2 and L by 4. Length is L by 4 and area of cross section is D by 2. B, D by 4 and 4L. 4L length is greater, D by 4 is coming. So as the area of cross section, diameter is lesser, then to the square times, resistance will increase. Okay? Then C, 2D and L, D, 4D and 2L. So all the 4 options are there. So here, if length is same, you check. No, all of them have different lengths. Then diameter check, D by 2, D by 4, 2D, 4D is there. So let's calculate one by one. R, okay, is proportional to or equal to rho into. First case you check L by 4 is a divided by D by 2 is the radius of cross section, diameter of cross section. Then to find area we have pi r square. So we can see pi d square by 2 you can make it. Is it? So it will be area is pi r square or it is pi d square by 4 will be. Pi d square by 4 will be the area of cross section. D by 2 is resistance, if you square it, d square by 4 comes in terms of diameter. So here, diameter here d by 2 is there. So it will be pi times, of course it is there, into d by 2 is the diameter, sir. So d square if you do, is d square by 4. So total will be d square by 4 into 4, 16. If you do it, it will become L by 4 it is. So it will be rho by pi, let be there. Then L by 4 into 16 by d square, that is 4 times rho L by pi d square. So 4 times R is coming. Case 1. Now if you substitute in this one all, you can get the second 2. R1 is the RA you can say. Then RB, check it. L is 4L. So it is rho by pi into 4 times L by D is D by 4 again. So there will be D square by 16 into 4 will be there. So it is D square into 16 into 4. That's a greater number, is it? 16 to 16 times comes. So that is B. Now C you check it. RC. RC will be 2D and 4L. L is given. So it is rho by pi into L by 2D is there. 2 into D square and be 4D square. So maximum diameter is there, then area of cross section will be greater and resistance will be least. So here RC is 1 by 4th is coming of rho by pi into L by D square. Now check D. 4D and 2L is there. So RD, you get it, rho by pi into 2L divided by 4D is there. If we square it, 4D square is 16D square. So 16 you get 1 by 8 times you get. So here see, the best way to check it, which have greater diameter, it will have least area of cross, least resistance will be there. It is because resistance is inversely proportional to area of cross section. As the thickness of the wire increases, the resistance decreases, we can say. So here the D, 4th one have the least resistance. Minimum resistance is the question, so D is the correct answer. 4D and 12. Let's see the next question. In the given circuit, the total resistance between X and Y is. So you have to find the total resistance between X and Y. One of the probable question in the question paper, it is the networks of the resistors. A figure will be given, you have to find the net resistance between so and so, the points. Here is given, we have 2 ohm, 3 ohm and 6 ohm. This way connected. By look like sometime the students will feel it is series. No, it is not at all series combination. See here, in between the wires are short here. Wires are shorted now, then the best way is, listen, 1, suppose you put this point 1, this is 2 and this is 3 and this is 4. So between first and 2, we have one resistance, 1 and 2, the point. Now between 2 and 3, we have another resistance and 1 and 3 is connected. 1 and 3 is connected and between 2 and 3, we have one resistance. Is it? So suppose here 2 and 3 one resistance is there. So one resistance, next one you put it. So it is connected between 2 and 3. Then 3 and 1 is connected here. Here see, first and second is in parallel comes. Then see, 2 and 4 is connected. 2 and 4 is connected. Between 3 and 4 there is one resistance. So between 3 and 4 one resistance there, and 4 and 2 is connected again. See, 2 is connected to 4, 1 is connected to 3, then between 3 and 4 one resistance. See how these are there? All the 3 are in parallel. So one is 2 ohm, this is 3 ohm and this is 6 ohm. So please keep in mind, different sort of networks are there. This way 3 are connected and they are shorted, then these 3 are in parallel. Keep in mind, in parallel. That's very important. You may feel it is series by seeing, but they are shorted, so they will become in parallel combination. Now, what is parallel combination resistance? We have 3 different values. So, 1 over Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 3 values are there. You substitute, that is 1 by Rp. So, that is 1 by 2 plus 1 by 3 plus 1 by 6. 2, 3, 6 are there. So, you take it as 6 as the LCM. Then 2 ohm. 2 you have to multiply with 3 to make it. So, 3 plus 3 you have to multiply with 2. So, plus 2 plus 1. So, 3 plus 2 plus 1. That is 3 plus 3. 6 by 6. That is 1. So, here 1 by Rp is 1 ohm. So, of course, Rp is equal to 1 by 1. That is 1 ohm. Here answer is 1 ohm is the answer. Option D is the correct answer here. 1 by 2 plus 1 by 3 plus 1 by 6 is 1 ohm. That is 1 by Rp. Take utmost care, my dear kids, because 1 by Rp is 1 ohm. Then you have to reciprocate this again. Rp you have to find out. So that is 1 by 1 ohm. That is 1 ohm. Please take care while calculation. Many of the students used to make the mistakes that after doing the calculation they will stop here after 1 by Rp. No, that is the value of 1 by Rp. The resistance effective is Rp. So you have to reciprocate. Okay. So take care about this equation. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So after getting it, again you have to reciprocate the answer. That will be the final answer. Okay. Let's see the next question. Consider the following combinations of resistors. We have 4 combinations are given here. All the 3 each, They are series, and in some cases they are parallel. In some cases, series plus parallel is there. Like first one, 2 are in series parallel. Second, all the 3 are in parallel. 3, 2 series each, then parallel is there. Fourth, both are in parallel. The combination having equivalent resistance 1 ohm is, which of them have 1 ohm resistance in equivalent? That we have to find out. So in parallel combination, if they are identical values, just we discussed that Rp will be R by N. If they are identical values. So you check first one, 2 ohm and 2 ohm are identical, you know. So first cases you can write it as Rp. In first case will be 2 ohm is value of 1. How many are there? Like that 2 are there. 2 by 2, that is 1 ohm again. Then second you check. 3 ohm, 3 ohm and 3 ohm. Total 3 ohms are there. So Rp, you can make it value of 1 resistance is 3. By how many are there? 3 are there. 1 ohm again. Normal case 1 by 3 plus 1 by 3 plus 1 by 3. That will be 1 by Rp. So Rp will be 1 ohm again. Then fourth one you check it. It is 2 ohm and 4 ohm in series. Then 3 ohm and 3 ohm in series. Together in parallel. So in series, you know, 2 plus 4 we have. Yes or no? That is 6 ohm. 3 plus 3 we have. So that is 6 ohm. So 2 6 ohms in parallel combination. So Rp will be 1 value 6 by 2, that is 3 ohm. So it is not 1 ohm. Fourth one is not 1 ohm. Which of the combination have 1 ohm is the question. Now fifth case you check. It is 0.5 and 0.5. 2.5s are there in parallel. So Rp is equal to 0.5 by 2. Value of 1 is 0.5. How many are there? 2 are there. So 0.5 by 2, that is 0.25. So that is not this. So except 4 and 5, 1 and 2, we have 1 ohm resistance. So option is C is the correct option for that. So different networks are given which all have the maximum or the equivalent resistance is 1 ohm. That's the question. Let's go for the next question. An electric iron of resistance 20 ohm draws a current of 5 ampere. The heat developed in the iron in 30 seconds is. So resistance is given, current is given, and time is given. You have to find the heat produced. From Joule's law of heating we know. Joule's law of heating. H, the heat energy produced in a conductor by the flow of current is equal to I square times R times T. I square into R into T is proportional to square of the density of current, proportional to resistance, then proportional time is there. So I square RT is the question. Here I is given how much? 5 ampere. R is given 20 ohm. Then time T is given 30 seconds. See, you have to check all the values are in SI system only. So no need any conversion. So it gives you H is equal to I square RT. I is 5 square times R is 20 times it is 30. So 5 square it is 25 times 20 into 30 is there. So 20 into 30 that is 600. 6 into 25 is 150. So 150 is there. Then double zeros. See the options. 15,000 joule, 6,000 joule, 1,500 and 3,000. So this is 15,000 joule is the correct answer. A is the correct option here. 15,000 joule is the correct answer. 5 square is 25. 20 into 30 is 600. Then 600 into 25 is there. So 150 and then 2 zeros. 15,000 joule is the correct answer. Hope you got it. Let's see the next question. Two resistors of 1 ohm and 3 ohm. 1 ohm and 3 ohm are connected in parallel in a circuit. If a current of 1 ampere is flowing through the circuit, so net current is 1 ampere. the current flowing through the 3 ohm resistor is how much? So on 3 ohm resistor, how much is the current? That is the question. Total current is how much? 1 ampere is given. In 3 ohm, how much will be there? So in parallel combination, take utmost care, voltage is same but current is different. Okay, so 2 are connected. Here 1 ohm is there and 3 ohm is there. So 2 resistors you contain this one. 1 ohm and 3 ohm. In parallel they are connected. Net current is given here. I is equal to how much? 1 ampere. If a current of 1 ampere is flowing through the circuit. So here V, we don't know how much. Here, methods many are there. 1 ampere is passing through it. So it will be divided into 2. But different current will be passing through 1 ohm and 3 ohm. It will be divided. More current will pass through 1 ohm, less will be 3 ohm. So in 3 ohm, how much is the current? That's the question. Either you can find the total voltage, then voltage across 3 ohm is you can get, then find I, how much will be there. Okay. So I1 and I2 we have to find out there. So I2 only is question. 1 ampere is given, 0.75 ampere, 0.33 ampere, 0.25 ampere is there. So we can see the net resistance RP will be 1 by RP will be 1 by 1 plus 1 by 3. That will be 1 by RP. So it will be 1 plus 1 by 3, that is 4 by 3. 1 plus 1 by 3 is there, that is 4 by 3. So RP is equal to 3 by 4 ohm. That is net resistance. And net current is how much? 1 ampere. Is it? So net current is 1 ampere. So voltage will be I into RP. IR is the voltage. So 1 into 3 by 4. So voltage is 3 by 4 volt. Hope you got it? So voltage is 3 by 4 volt. Now across 3 ohm also voltage is 3 by 4 volt. So current through 3 ohm, I across 3 ohm is equal to V by R we have. V by R. So that is equal to V is how much? 3 by 4 is there. Divided by R is how much? 3 is there. So that is 3 by 4 by 3. That is 3 by 4 into 3. That is 1 by 4 is equal to 0.25 ampere is answer. So 0.25 ampere will be the current passing through the 3 ohm resistance. So my dears, methods, any method you can use it. So you can find the voltage across 3, then find the current through 3. Because voltage is same in parallel combination, not the current. If it was series combination, just directly you can find how much 1 into this 3. Hope I got it. Let's see the next question. 2 wires of same metal have the same length, but their cross-sectional area are in the ratio of 4:1. They are joined in series. The resistance of the thicker wire is 20 ohm. The total resistance of the combination is, one of the good question it is. So given same metal, therefore we can confirm rho, the resistivity is same. Then length is same. So L also same for both. Then is given there, the cross-sectional areas are in the ratio of 4:1. So suppose rho 1 is equal to rho 2 is equal to rho, you can write. L1 is equal to L2, that is equal to L, both are same. Now A1 by A2 is equal to 4 by 1. So from this equation, you can write, you multiply it, 1 into A1 is A1. So A1 is equal to 4 into A2. So area of cross-section of the first one is 4 times that of A2. So who is thicker? The first one is thicker one. The thin one is A2. Second one, it's 4 times thicker area of cross-section of first one. So given here, they are joined in series and resistance of the thicker wire is 20 ohm. So we can say R1 is equal to 20 ohm as mentioned in the question. Now they are contained in series. Your question is total resistance of the combination is how much? Total resistance will be how much? That's the question. So R1 is 20 ohm. R2 you can find out because L is same. So in this concept, series combination RS is equal to R1 plus R2. R1 is given 20 ohm. R2 you have to find out. Then RS we can read it. So what is R2? R2 we can write as R2 is equal to rho into L by A2 I am writing. Why? It's because rho into L is same and A2 is there. Now R1 is how much? R1 is equal to rho into L by A1 we can write. If you find the ratio of these two, then R2 is very easy to find out. Is it? So here we can write in this concept R2 divided by R1 is equal to, if you divide the RHS, rho L cancels. So it will become rho into L by A1 divided by, A2 divided by rho into L by A1 is there. So if you cancel there, rho L cancels, then A1 go to numerator. So the final answer will be R2 is equal to R1 into A1 by A2. What is A1 by A2? We have 4 by 1 or 4. So 4 into R1 will be R2. So that is equal to R2 is equal to 20 into 4, that is equal to 80 ohm. So R2 we got 80 ohm. R1 is 20 ohm, then it's 4 times will be R2. How we got 4 times? This is the method to divide both sides. So ratio if you take it now, it's easy to calculate. Or you can substitute for A1 here from the other equation, A2 you substitute, then do that way. Have we got it? So now total resistance, RS is the question. Here 80 ohm, here 20 ohm. 80 plus 20, how much? 100 ohm. So option B is the correct answer here. 100 ohm is the correct answer. Pause the video and practice it again. You got it or not? Let's take the next question. Assertion and reason type question it is. Assertion. Electrons move from lower potential to higher potential in a conductor. Yes, it is correct. Because electrons are negative charged. So it's moved from negative to positive of the battery. So that is lower potential to high potential. But direction of current, that is from positive to negative of the circuit. It is because direction of current is same as that of positive charge. That is a conventional direction we have. Electrons move from negative to positive, that is low potential to high potential. That is correct only. Reason. A dry cell maintains electric potential difference across the ends of a conductor. Sure, dry cell if we conduct, then we are getting an electric potential difference. One will be low, other will be higher. So dry cell is a source of potential difference we can say. There should be a potential difference always across a conductor and only current will pass through it. So both are correct and correct explanation A is the correct answer. Both assertion and reason are true and reason is the correct explanation of the assertion. Have I got it? Next question, let's see. If 4 identical resistors, all of them are same values of resistance 8 ohm are first connected in series so as to give an effective resistance of RS and then connected in parallel so as to give an effective resistance RP, then the ratio RS by RP is very easy. Only 2 types of questions we gone through before. RS, if there are identical, N into R. R is the value of one resistance, N into R will be that one. We have how many? 4 are there identical. We don't know. One is 8 ohm. So it will be N is how much? 4 into 1 half 8. 4 into 8. It will be 32 ohm. Now, if you count them in parallel, identical resistance RP is equal to R by N we have. RP is equal to R by N. Value of one resistance divided by total number. Value of 1 is 8 ohm. So its value will be in parallel 8 by, how many are there? 4 we have, 8 by 4, that is 2 ohm. So in parallel we have 2 ohm. Series we have 32 ohm. Now question is RS by RP. The ratio of RS by RP will be equal to 32 divided by 2, that is 16. So option D is the correct answer. So separately you can find it or take the ratio. Okay, hope I got it. Next question. It's a practical oriented question. We can say, in the following diagram, the position of the needle is shown on a scale of a voltmeter. So on a voltmeter is mentioned. The least count of voltmeter and the reading shown by it respectively are. You have to find the least count and the reading how much is showing now. Any measuring device, the least count is the minimum reading which you can measure from that circuit. So here, for that to find out, least count, always take here any measuring device. If it's a scale, or it's an ammeter, it's a voltmeter, it's a speedometer, it's an RPM meter, any it can be, to find the least count. That means value of one division, how much? To find that one, see, it is 0 here. After that, 1.5 we have the highest value. 1.5 we have the highest value. Between 0 and 1.5, how many lines are there you can check. Or 0 to 3 you can check it, how many lines are there. Both are fine. So any one value, maximum you take it. So, or 0 to 3 you take it. It's easy to calculate, I am saying. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 divisions are there till 1.5. And till 3 we have how many? 20 divisions. So any one of the main scale division you take it. Main scale means these values. 1.5 or 3 you take it. Divided by number of divisions. So it is 1.5 divided by 10. That is 0.15. So 0.15 volt is the least count. Now what is the benefit of getting least count? This least count will be value of one division. Then if you want to take the reading, check how many line the needle is showing. Multiplied by 0.15 will be your answer. Check the values. Here say after 10, 11, 12. On 12th reading is there. This is on 12th one. So the reading of the voltmeter will be 12 into 0.15. 12 into 0.15. So it will be, see the options now. Least count is 0.15. So of course it's not B, it's not D. Now reading is 12 into 0.15. So it will be how much? If the current I through a resistor is increased by 100%, constant temperature is there, so current is increased by 100%. The increase in power dissipated will be how much? So temperature is kept constant there, current is increased 100%. That means you doubled the current. Doubled the current. Temperature is kept constant is given. So temperature is kept constant means then resistance will be this kept constant. Yes or no? So if power is, how much can it be? So for the power we have different equations we have. The most basic equation of power P is V into I. V into I is there. Or it can be P is equal to I square times R, it can be. I square times R it can be. So if temperature is kept constant, then resistance of the circuit will be kept constant, remain constant. Then if current you increase 100 times, by changing the voltage it will be. So at that time, 100% increase is there. That means current become double. I dash will be 2 times I. 100% increase means the original current I is there plus 100 into I by 100. That means 100% increase. That is 2I will be. So if I become 2I, then P is proportional to I square it is. So to the square of the 2, that is P dash will be 4 times I into R. The new power will be 4 times the original one. So P dash is 4 times P. To become 4 times, how much increase should be there? If 100 times increase, it is doubled. If 200 times increase, it is tripled. If 300% increase there, it becomes 4 times. So answer is C is the correct answer, 300%. In lower classes in mathematics, you might be studied how much is the percentage change to find out. The percentage change, you can find the percentage of change. We can say it will be equal to the change in power divided by original power into 100. So change is how much? 4p minus original p. So 3 times is the change. That is, change will be new power minus original power divided by power into 100. So from this concept we are getting, it is 300. 4p minus p is 3p. 3p by p, that is 3 into 100, that is 300%. That's the mathematical equation to find the change. So anywhere the percentage change question comes, you can use how much change is there actual divided by the original into 100 will be the answer. Hope you got it. Let's see the next question. For verifying Ohm's law, we design an electric circuit diagram in which we show the arrangement of different circuit components. We find that with respect to the resistor, so regarding Ohm's law circuit, the question it is, ammeter is connected in parallel and the voltmeter in series. Ammeter is connected in series and the voltmeter in parallel. Ammeter and voltmeter are both connected in series. Ammeter and voltmeter are both connected in parallel. You know, in Ohm's law circuit, voltmeter should always be connected in parallel and ammeter should be in series. So here, ammeter is connected in series and voltmeter is parallel. B is the correct answer. I hope you might be knowing what is the reason. Because ammeter is a low resistance device. Its resistance is very low, ammeter. So if that you connect in parallel, what happens now? The total resistance of the circuit will decrease and net current increases. So circuit may damage. So ammeter should be connected in series. So a small resistance is connected in series, it do not affect the resistance of the circuit. So normal current will pass through it. Voltmeter, it is a high resistance device. Hence, if it contains series now, the net resistance increases and least current will pass through. Hence, it is contained parallel. So why they are contained series and parallel? If anybody have doubts, it is this because ammeter is a low resistance device and voltmeter is a high resistance device. If a higher value contained parallel, no change will be in resistance because the near current how much is there? The same current will pass through it. Let's go to the next question. In a resistive circuit, if the current is increased to 2 times, so current is increased to 2 times, the percentage change in the amount of heat dissipated in the circuit will be. So how much is the percentage change in heat will be? That's a question. So current heat equation we have I square R into T. In a resistive circuit, here the resistance is constant. So current is doubled. If you double the current, so then 2 times increase, no? So new current I dash is 2 times I. Then R and T is same. Then here H is proportional to I square. Heat is proportional to square of the current. So new heat will be proportional to 2 times 2I the whole square. That is 4 into I will be. So just previous question we done. If heat become 4 times increase, then there is a change of 300%. Yes or no? So the answer is again B here. In the power question we got it same way. So how to find the change? The change in the heat, how much? 4H will be there. So 4 times it increases. Is it? So it will be proportional to 4I. That gives H dash is 4H. Is that fine? Okay. So then divide this one. So it will be 300% increase will be there. So I square to the square times of current, H is proportional. So I doubled, then it becomes 4 times multiplication will be there. Okay, it's fine. So here is the next question. 2 LED bulbs of 12 volt and 6 watts are connected in series. If the current through 12 watt bulb is 0.06 ampere, then current through 6 watt will be. See, in series combination, we know that same value of current passes through the circuit. Here, 12 watts and 6 watts are contained in series is mentioned. Hence, in series, same current will be there. How much? 0.06 ampere. So, B is the correct answer. See a question? No need to do any calculation. Without calculation itself, you can say how much current will pass through 0.06. So, it is 0.06 will be passing through. Next question. The resistance of a resistor is reduced to half of its initial value. Resistance is become half. If other parameters of the electrical circuit remain unaltered, no changes there, then the amount of heat produced in the resistor will become. So, the same concept is there, resistor is halved. So, we have heat produced is equal to I square R into T. One equation we have. Or it can be H is equal to V square by R into T. So, normal case, if resistance is decreased, current will be increasing. So, which can be other parameters kept constant will be voltage and time. Voltage and time is kept constant. If voltage and time is kept constant, then H is proportional to 1 by R. So, in the second concept, we can get it, H heat is proportional to 1 by R. If V and T are constant. Voltage and time are constant, then H is inversely proportional to R. So, here resistance is halved. Is it? So, the resistance of a resistor is reduced to half of its initial value, half. If resistance is halved, the heat will be doubled because it is inversely proportional. So, it will become 2 times will be the heat. B is the correct answer. So, it's have 3 or 4 equations you can get it. Power into time is one equation. V square by R T is one question. V I T is another equation. I square R T is another equation. In that one, which all parameters can be kept constant? Though you change the resistance, it is V square by R into T. Hope you got it. So, next question. The expressions that relate Q, I and T, charge, current and time, and Q, V and W, the work done, voltage and charge, respectively are. Here the symbols have their usual meanings. Okay, concept. We have I is equal to Q by T and V is equal to W by Q. So, in this equation, see. So, from here we can have Q is equal to I into T. Then here we can have W is equal to V into Q. Q is equal to I into T, W is equal to V into Q. We have. So, check the equations. Yeah, option B is the correct one. Q is equal to I into T, W is equal to V into Q. So, in the alteration form, you have to get it. Basic equation you should know. I is equal to Q by T and V equal to W by Q. That you should be thorough about it. Let's see the next question. SI unit of electrical resistivity is, see, in another way it is asked, it is what? Ohm meter. We done in the beginning. So, another set of question, it is 2023 question paper. SI unit of resistivity is what? Ohm meter. It is resistivity we have is equal to resistance into area of cross section divided by length. So, ohm into meter square by meter, that is ohm meter. Next question. You have a thin resistance wire having a thick plastic insulation. A decrease in resistance of this wire would be produced if somehow we increase the. So, how to change the resistance? You have to decrease the resistance again. Already you have thin resistance wire it is. You know, resistance is inversely proportional to cross section area. Is it? So, thickness increases, resistance decrease. One main idea, sir. Check the options. So, decrease you have to do. So, to decrease the resistance of this wire, thickness can be increased. Check. Thickness of the plastic insulation if you increase, no matter. Insulation have no concept, no link with the flow of current through it. Temperature of the wire you can increase. Of course, if you increase the temperature. Length of the wire you can increase, then resistance will be increase only. It cannot decrease. Then diameter of the wire you increase. That's the best idea. So to increase the resistance, somehow it can be increased. You have a thin resistance wire having a thick plastic insulation. So insulation and with this no matter. Okay, wire is thin. A decrease in the resistance of the wire. Resistance should be decreased. For that purpose, what you should increase is the question. With plastic insulation, nothing to do. Temperature increase, resistance also increase will be. So it cannot be. Length of the wire increase, resistor increase. No. If diameter increased, area of cross section increases and resistance decreases. So D is the correct answer. So here R is proportional to L by A. Okay. So area of cross section increase, resistance will decrease. Diameter have to increase it. That's the question. So my dears, here is this few MCQ questions from previous year questions from different regions. We collected. Please pause the video and practice each one thoroughly. You should be familiar with all of the equations of the chapter and all the concepts. See, almost all the topics came here. Regarding heat, we done the question. Regarding power, we done the question. Regarding combination of resistors, series and parallel, we done the question. Regarding resistivity, we got the question. Regarding Ohm's law, we got the question. Their practical idea also. Voltage, we got the question. And current and charge relation also, we got the question. So hope you understood it clearly. See you in another video lesson. Stay tuned. Thank you for watching.